Oh my gosh, we're live on YouTube. Okay. Don't talk. Okay, so here's what we're going to do. We're going to do a quick little demonstration of convection. All right? This is going to be awesome. Okay? And you're going to laugh at my jokes, even if I don't make any. Okay? So here's what I'm going to do. I have some red dye, and I'm going to use this thing. This is called a micro pipette. I know this looks like really tragic. But I'm going to use a micro pipette because I need this red dye to get in an exact location. So I'm going to stick this in there and kind of put it right there at the bottom of the tray. And sure, some of it's going to sink up, and that's okay. All right, so we got red dye over there. Now, I have really, really, really hot, like really hot water here. This is really hot, you guys, and it's actually going to burn me, so I'm going to set this right there for just a second and get my hand out of the way. Okay, so we got some hot water. This is really hot, and it's right now starting to burn my hand, which is really awesome. Okay, and I'm going to go stick this over here, and we're going to put it right underneath, without moving this too much, right underneath the red dye. So if you look on the screen, I got to lift this up a little bit more because we're stuck on something. There we go. Right there. Okay. So you can kind of start watching that red dye and see how it behaves, because it's actually going to be pretty cool. Okay. All right. Now I'm going to take this blue ice and I'm going to very, very carefully set it over here and try to keep it on this side. Okay. So I will grab this here ice cube. Michaela, do you think you could get me a paper towel out of that paper towel dispenser? Try not to move this too much. Want that to stay right there. Okay. And now we're going to watch. Okay? So what's happening to the red? Yeah, it's totally floating up. In fact, it's like streaming up. It looks super cool. The hot water underneath, evaporating, is really heating up that spot under the red. It's heating up the red water. It's making it less dense than the water around it, and so it floats, just like a hot air balloon does in air. Okay? What's happening to the blue ice as it melts? Yeah, it's right. It's expanding. It's going to the bottom. It's sinking. It's harder to see, but it's heavier than the water around it, so it's going to start to sink. Okay? And if you watch, and it's subtle, and it takes a little while, and in the mantle of the Earth, this would take even longer, but you'll start to see that we've got a convection current starting. Okay? Notice that the blue water is scooting along the bottom, and it's headed towards the red spot, and the red is now going along the top and heading towards the colder water. Okay? It's all because something has to fill the space of the stuff that is leaving. So if the red water is going up because it's rising, it has to pull water from somewhere else in the dish to fill that space. And because that water has left, something has to fill the space that it left. And so you get this current that's going to keep going. Now eventually you'll just get a whole dish of a purple mess. But for a while at least, this will be totally visible where you've got this cool little current going. Okay? Now, if you're in the Earth, if you're in the mantle of the Earth, imagine what this does. Because the one thing we don't have on this dish, we don't have a crust sitting on top. The Earth has a crust sitting on top. So if you have these currents happening underneath the crust, okay, what is that going to do to the crust? It could wear it down, maybe. What else? Well, as it's rising up, what could happen? Yeah, you get volcanoes, okay? But what the other thing that's happening is as it comes up, it's then being forced to the side. So it's coming up and pushing and then moving along and like rubbing along the bottom side of the crust, which could do what to it? Especially because this is with a lot of force and a lot of friction. What's that going to do? Certainly going to make the Earth move, the crust of the Earth move, which is going to give you some earthquakes. But it's going to fracture the whole crust of the Earth. You're going to get places where it's going to crack, and you get these things we call plates. And you've probably heard of plates because you've probably heard of plate tectonics, and if you haven't, you will in this class. Okay? But the whole surface of the Earth gets fractured, and those plates move around, and they shift because of all that stuff moving underneath of them. Okay? And sometimes you see pictures of convection currents, and like there's one here, and then one here, and then one here, and they're all like perfectly lined up in the mantle. They don't do that. They're unpredictable. You get a convection current here, a strong one. You get a weaker one over here, and some of them go sort of in this direction, some of them go in this direction. So these plates are constantly like shifting around and cracking and moving in different directions. And yes, that's what causes us to have a lot of our volcanoes. That's what causes earthquakes. That's what causes whole plates to go under other plates. So all of plate tectonics really is being driven by this process right here, which is, you know, at least at this point, it's going to just start getting purple now. So I'm going to leave it up during the period. I'm going to shut off YouTube. Say bye, YouTube.
Bye.